Hello, in this lesson we are looking at some of the variations that exist of the parent equations. Particularly we're looking at what's known, often it's called the standard form of an equation. And so we're going to want to graph a standard form, an equation that's written in standard form. Also, we want to write an equation that's written in standard form, given a graph. Okay? Before I go to the next slide here, what I want to do is go ahead and write for you the standard form of an equation. All right, and you're going to want to write this as well. Say that it is y equals a times the quantity x minus h, quantity squared, plus k. In particular, you see here that I've used the quadratic, the parabola, the quadratic equation, but we can have other standard forms. We can have a standard form that looks very similar to this for other types of parent equations. For instance, you might have something like this: y equals a times the square root of x minus h, all of that plus k. This is for a quadratic. This is for a square root. So, a couple things that's important here to note. The k deals with a vertical shift. K, vertical. All right. That's how I remember it. The h corresponds to a horizontal shift. And the a corresponds to a vertical stretch. Now, you might stretch it, or what's the opposite of stretching?
Smush it.
Smush it? Is that the official word?
I don't know, but I might be smushed.
It deals with a vertical stretch or smush. I think that is the official mathematical term. Okay, so you can stretch it vertically or you can smush it vertically. All right. So these are the important facts that you will need to carry along with you in this lesson. Let's look at we ready?
No.
Okay, so let's look at some problems and see how this goes. What we're looking for is how to graph this equation. Now, yeah, anybody could enter this into their graphing calculator, but let's suppose you were stranded in the middle of the desert and your life depended upon you graphing this in the sand. What are you going to do? You should start off by finding your starting point. So this gives us these directions. It says circle H. So let's circle H right here. Let's circle it. Now notice, I'm going to leave that negative alone. I'm going to circle the number only. It says if the operation listed is minus, then you move right. If the operation listed is plus, then you move left. That should be a big question mark to you. What in the world does this mean? We're going to discuss it in just a moment. Now that it says circle K, K is this guy. By the way, this little square here, I don't know why there's this space. That square should go right here, and everything should just be moved over. This space should be eliminated. But K, we're going to circle it. There it is. So, this also says if the operation is listed is negative, then move down. If the operation listed is positive, then move up. What does that mean? We're going to find out very shortly. So, here's the starting point. What is H in this case? 3. What is K? 4. So the starting point is 3, 4. Now notice. I'm going to get rid of these question marks now because I'm going to explain to you what they mean. This says x minus 3, right? Notice that the point that we just pulled out is positive 3. So if the operation listed is negative, then you move right. You think about positive, move left. Here's what I mean, the starting point for this graph. The original quadratic graph looks like this. All right, this is y equals x squared. That's the apparent graph. All right. So where is 3, 4 going to live? Where does this point right here live? It lives 1, 2, 3 to the right, and 1, 2, 3, 4 up. So I'll put a point right there. This graph will look something like this. Okay? That's what we just did. We plotted that point. Okay, so your next point, look at the A value. The next thing you do is to look at the A value. All right, now on the last slide, I've drawn this. this is the exact same equation as what we were just looking at. Same equation. And we went to the right 1, 2, 3, and up 1, 2, 3, 4. That was our starting point. Now we're going to look at A. This value right here, A equals 2. So the directions say from your starting point, move one place to the right. If A is negative, move down A spaces. If A is positive, move up. Move up A spaces. So A was 2, so I would go up 1, 2, and plot my point. So the first point you see we listed was 3, 4. The second point that we listed was 4, 6. All right. So it says plot this point. This is your second point. So we're trying to figure out how to graph an equation that's written in standard form. And these slides here walk you through that process. We're going to plot one more point on this graph. In order to do that, I know that I'm able to maybe copy and paste this. We'll see.
Is this on the website?
It is about to be after I post this video. All right. So you have this explanation here. Your third point. It differs on the type of parent equation that you're working with. You have a square root, you have a cubic, you have a quadratic, you have quadratic and absolute value. Here was cubic and cube root. These are how you find your third point. All right. So we're doing a quadratic graph right now. And it says move from, it doesn't say from, yeah, up here it says one space to the left of the starting point, and then you will move up or move down depending on what A is. So if I came back to this graph here, how do we find our third point? The directions that was on that last slide, it said you move one unit to the left of your starting point and then up or down depending on what those directions were. In this case, a quadratic graph would be you would go up A units. So A was 2, if you remember. So we'd go up 1, 2. And there is the first 3 points on our quadratic graph. Now, our goal was to make a sketch and a sketch only. So you can draw this right here, make a nice smooth curve. And that is the first step. I mean, this is the first example of how to draw a graph written in standard form. Okay, so in the next lesson, we'll do a few more examples of this and really lock this down. All right, thank you for watching.